Hello, welcome to this lecture video. So I am teacher Melai. So today we will be talking about statistical assumptions. So what is an assumptions or what is the assumptions? So it can be interpreted as requirements of inferential test. It can also be direction for appropriate use of a product or the test, and it explain when it is or when it is not reasonable to perform a specific statistical test. So of course, dealing with the assumptions, we actually have two options whether we're going to use either parametric test or non-parametric test. But first, we have to consider what is the problem all about. So is it just simply to describe? Then, of course, if your objective is to describe, then you don't need to use either parametric or non-parametric test. So you just use any of descriptive statistical test. Or if your problem now deals with inferential statistics, so you also need to check whether it is for comparison, for differences, for exploring relationships, or determining if possible or variables or indicators or not. And we have a list of variables, or rather a list of inferential statistical tests under parametric, and also a list for its counterpart in non-parametric tests. So which means just in case that you cannot, or you did not, or the data rather did not satisfy the condition for a parametric test, then we have a counterpart in non-parametric test. So talking more about parametric tests, so the common parametric tests are, so we have the t-test, we have ANOVA, we have Pearson R as parametric test. So it is designed for data that have certain characteristics, including approximately normal distribution. So for parametric tests, so you have first to check for the nature of your data. So is it at least interval? So in our discussion in the descriptive statistics, you were taught, of course, to identify the scale or the level of measurement. So at this point in time, so you must know already how to determine the nature of your data. So if you know that your data is at least interval data, so you need to check if you can use parametric test. So this is just an initial assessment because as mentioned, you have also to consider the type of your, or what is your question all about. So you have to check if your data is at least interval, and then also check if your data is normally distributed or not. So we have more assumptions in parametric tests compared with non-parametric tests. So in case that you failed to satisfy the conditions or the assumptions for parametric tests, we have an counterpart in the non-parametric test. So this is often used when the assumptions of parametric tests are violated. And it can also be used now for data which is not interval, not ratio, because it is categorical, either nominal or ordinal. So we also have tests for that. And then aside from that, of course, here is now the common assumptions. So the list or the following. So we have homogeneity of variances, normality, independence of observations, and linearity. So this are the common assumptions of parametric test. Okay, so for homogeneity of variances, so we have to check if our variances are equal or it is not equal, because this affects our data. So just in case later that you find that it is not equal, then you have an alternative test again also for that. And then for equal variances not assumed, so The test that we used here is Levin's test. So this is actually considered as a critical, one of the critical assumptions, because as mentioned, it can affect the result. And then for the normality, so we say that our data is normal, or it is normally distributed if the shape is asymmetrical bell shape or a normal curve. That is when you use, for instance, histogram. So we actually have several ways to check for normality, and this will be discussed in a separate video. Now, for the independence of observation, so this is an assumption that there's no relationship between the scores for one person and those of another person. So usually this is affected, for instance, by using non-random sampling, like let's say a snowball sampling. So it can be that one individual recommends someone who is of the same characteristics as him or her. So of course, this is some of the circumstances that we have the violated the relationships, that there's no relationship rather between the scores of one person and those of another person. Or even when we are selecting, for example, a class, so if it is homogeneous class, because the students or group, when they of course have the same, for example, cutoff of average and all of the sort of things. And then the last one is linearity. So for linearity, this is assumption that two variables are related in a linear fashion. So of course, if it is related, we are it is expected that the graph here, when you constructed a scatter diagram, maybe is a line, so it forms a line. Or we already know that as the variable, for example, if it is directly correlated and it's a line, linear, it has a linear relationship. So as one variable increases, the other variable also increases. So these are some of the assumptions that we need to check for each of the test. So in other videos that we are going, or lessons that we're going to discuss, so we are going to have a separate video for each of the tests and determine what is or are the assumptions of the test. So this is all for this video. Thank you for watching.